Unleash African architecture. Concrete is the most important construction material available. Especially when you use precast concrete, the possibilities are limitless. Combined with African-style elements, it will generate amazing results. To produce the best precast concrete products, we however need a massive production facility. This factory will not only produce all elements for future African cities, the factory also will build its own factory hall.
In this animation you see how it is done and how many days it will take. Using precast concrete elements that are produced on a conveyor belt has been the most efficient solution for affordable and high-speed mass housing. The conveyor belt with tables is also known as a precast concrete carousel. The main problem with traditional precast concrete is that it still needs a lot of on-site finishing work that reduces speed. Also, because of the lack of skilled artisans in Africa, on-site work reduces quality. Another big issue of traditional precast concrete construction is that the massive repetition bites creativity. To solve this, Betoniq added various innovations to the precast concrete construction method. These innovative solutions use the benefits of the highly automated carousel but also enables almost unlimited individual creative building designs. Let's zoom in on the different stages of production in the factory to see how it works. The heart of the factory are the precast concrete tables. These are massive, perfect straight steel tables of about 4 by 12 meter. The highest quality precast concrete tables are produced in Eilenberg, Germany, near Leipzig, by the company Abawe, which is a subsidiary of the Italian Progress Group. These tables are placed in a conveyor belt kind of setup. The first major Betoniq innovation is to use the tables in the carousel for both wall and floor panels and also finish these panels fully in the factory. So on-site work is reduced to a minimum and quality and speed is increased to a maximum. A factory with one carousel line will produce about 500,000 square meters of slab, which is about 2,000 apartments, and will employ about 400 people that work in 2 12-hour shifts. In our factory layout we use 25 tables in the carousel. Each table is used twice a day. Let's take a look at all the stages of these tables in the carousel. The first stage is cleaning the tables. Remaining cement and remains of Tempex are removed by a large brushing machine. The second stage is where the shuttering robot places the heavy steel shuttering beams exactly on the spots that are retrieved from the Betoniq parametric design of the panel. The beams are fixed to the steel table by the integrated magnets that are activated by the robot. Various parts of the Betoniq frameless door and window design shuttering is also being placed by the shuttering robot. Because the accuracy of the precast concrete carousel system is so incredibly high, and sub-Saharan African buildings don't need insulated glass or walls, the rabbets are all cast in concrete and hold a groove where a rubber strip can be pushed in. By applying tempered glass that can hold anti-burglary foil, and gluing the hinges directly on the glass, or by using proper straight wooden door panels with special hinges, and by casting the feet of the hinge directly in the concrete, no wooden, aluminum or plastic door or window frames are needed in the Betoniq designs, which again is a massive financial initial saving, a huge improvement of quality and a massive reduction of maintenance costs. The third stage is where the 3D printed form liner molds are placed on the table. The molds are produced in the factory workshop using 3D printers and CNC routers and stored and labeled in special storage bins close to the carousel. For the heavy formliners, a small dedicated overhead crane is used. These 3D molds are positioned by hand using a monitor that indicates which molds goes where exactly. Special corners of the Betoniq frameless door and window system shuttering are also manually applied here. In the fourth station, a special robot automatically sprays a releasing agent on all the parts that will receive concrete. These are parts of the surface of the table, the shuttering and the 3D molds. Before we go to the fifth station, in a separate workshop in the factory, the rebar mesh is being prepared. Again, based on the Betoniq parametric design of the panels, the Progress Mesh welding plant straightens rebar rods that arrives at the factory wrapped around a coil. After straightening, the robots of the mesh welding plant cut the rebar rods of different diameters and position them in the indicated locations. After positioning, the robots weld the rods together in a way that a dedicated mesh is created that serves only the necessary strengthening of that particular wall or floor panel. By being able to only put rebar steel where it is really needed, about 30% of rebar steel is saved compared to traditional mesh reinforcements, which is a massive financial saving. The mesh includes position rods for special items like connectors that are used to connect the walls to the floors and to connect the floors to other floors. The mesh is also used to connect sockets, electricity and water tubes, sewage tubes and other fittings for lamps, heating and cooling devices and anything else you want to cast into the concrete panels. Much of these items are already mounted on the rebar mesh before it arrives at the carousel. In the fifth station, another robot positions special spacers to make sure the concrete can properly get in between the wall surface and the rebar mesh. Once the spacers are positioned, the rebar mesh is positioned properly on the table and remaining fittings are positioned manually, again indicated on a monitor next to the station. Once the manual labor is ready, a special camera takes pictures of the setup that is prepared on the tables. The pictures are compared with the actual design of the panel by our quality management department. This to be sure no mistakes have been made before the concrete is being cast. Also, the workers are filmed 24/7 to give the quality management full input for quality and safety improvement. Before we go to the sixth station, in another department of the factory, the concrete mixing plant, the concrete is being mixed in the best atmospheric conditions, with the best possible concrete mix for our specialized Betoniq system that requires perfectly smooth surfaces that must be able to receive direct paint 4 days after casting. The concrete mixing plant also feeds the concrete trucks that are used to do the on-site casting of foundation blocks and also feeds the flying bucket that flies to other parts of the factory to deliver concrete mix to the street objects department and to the large building structures department. In the sixth station of the carousel, a special concreting robot pours exactly the required amount of concrete on the fully prepared table. After the concrete is cast, the table moves to the seventh station, where the concrete is compacted by forcefully shaking the entire table. After compacting, the table moves to station 8. In this station, the top side of the panels are first leveled with a special leveling beam and are next being smoothened by special smoothing helicopter robots which use different types of rotors in 3 runs to get this side of the panels perfectly smooth. By creating perfectly smooth panels, the buildings need no plaster work or on-site scaffolding, which is again a massive savings. In station number 9, the entire table is shifted in a curing oven. In this oven, the table remains for a minimum of 6 hours at a temperature of about 70 degrees Celsius. After curing, the table is moved to station 10 where the shuttering is removed by another shuttering robot. The shuttering beams are put on a transporter that runs the shuttering beams through a cleaning station before another shuttering robot picks the shuttering beams from the transport belt and stores the shuttering beams in a well-organized storage space. Because the Betoniq design uses 3 different shuttering heights of 11, 14 and 25 centimeters, and the shuttering needs to vary in length as much as possible, a huge amount of different shuttering beams need to be constantly available here. The logistics of the shuttering is a very complex and important part of the logistics of the factory and is closely related to the Betoniq parametric design. Once the panels are freed from their shuttering, the table moves to the 11th and last station of the carousel. This is the tilting station. In this station, the table is tilted almost 90 degrees. Different than any other carousel in the world, the Betoniq system needs a special hoisting beam to be able to lift all different concrete panels in one hoisting movement from the table. This is necessary because of the logistics in the storage and painting department of the factory. By combining all panels of one table, hanging on one hoisting beam, the number of hoisting movements of our overhead cranes is reduced with about 70%. This was necessary because otherwise, the overhead cranes were not able to keep up with the production of the carousel. Because the distances in the 150 x 60 meter factory are big, it is simply not possible to move 150 to 200 panels multiple times per day with the relative slow overhead cranes. Once the panels are hoisted from the table, the hoisting beam with panels is placed on a special carriage that moves the panels to the storage and painting department. The form liner that was covered by the concrete panels can now also be removed, cleaned and being stored in the special form liner storage bins. The hoisting beam with the unpainted panels is finally stored in the product storage section, where the concrete will dry for 4 days. Special ventilation in the storage area is used to make sure all water leaves the concrete panels. After 4 days, the hoisting beam with the concrete panels is moved to the painting section where several painting robots and manual painters use about 4 hours to paint the panels on all sides. The human painters use monitors to see exactly how the panels need to be painted. The robots use the information that is provided by the Betoniq parametric design. Most robots will apply only 1 or 2 colors, but there will be also some inkjet printing robots that can print the full spectrum of colors, even on surfaces that have structures from the form liners that are not too deep. The printing will use 2 or 3 layers. 3 layers are applied for floors or for walls with multicolor paint applied. The third layer is to protect the surface for heavy floor duty and against the harsh African weather. After printing, the hoisting beam is moved to another storage area, where it will get another day to dry properly. Another very special application that will be added to the factory is the 3D concrete printer. This printer with the size of a hotel room will allow us to 3D print an endless variety of objects, like concrete furniture, concrete statues and concrete panel additions, like open concrete screen mesh or Roman-style columns, to enrich the wall and floor panels. Next to specialized molds for stairways, these special features will maximize the creative possibilities of the factory. Once the panels are ready for transportation, they go to another tilting station. 2 tilting stations are used to remove the hoisting beam of walls and to have some time to apply window, door or sunscreen panels while the panel is in a horizontal position. Because walls are transported in a vertical position, the tilting station puts the panels vertical again before the overhead crane places them on the trailer rack and the truck drives them out. Floor panels need to be tilted in another direction and are transported horizontally on a flatbed trailer. As mentioned, the factory also has several other departments. The Street Objects Department produces objects like pavers, curbs and sewage elements for the street work around the projects of the factory. The Large Building Structures Department produces columns, beams and roof elements for large buildings like factory halls, sound stages and shopping malls. The factory also has an advanced workshop where 3D printed molds and form liners are produced, but also where many other little chores are done, like repairs of trucks or where the molds for the foundation blocks are produced and repaired. Also tasks like the preparation of door and window panels, the production of hinges and the rubber door and window strips are done here. The factory also has a concrete lab where specialized tests regarding concrete mixes and painting applications are being tested. There is also some office space in the factory with toilets, locker rooms, restaurant area, and room for the management, logistics, quality control and security. This is how the most advanced precast concrete factory in the world looks like. Now we continue with the on-site assembly. Once the laterite is applied on the road, trucks with the molds of the foundation blocks arrive. 96 blocks are positioned and filled with concrete every workday, which is 1 per 7 minutes. Also the formwork for the floor of the septic tank and the concrete waste bin are made and filled with concrete. How we use lasers to level the precast panels. The leveled lasers emit light on a level stick to mark rebar sticking out of the foundations. Discs are used to support the floor elements. Then we apply special molds on the foundations. We add kit to close and strengthen the cavities. This way the mounting cement won't leak away when the walls are positioned. How was that floor panel hoisted? Floor panels arrive on a rack on a flatbed truck. This way trucks don't need to wait on the site. We use a special hoisting beam for safety reasons. The telescope crawler crane suits the small site. It works close to the panel racks. It positions the panels very accurate. Connections are made with a special concrete mix. It fills the holes in the foundation blocks and floor. Rebar sticking out the bottom of the walls connects 3 elements in one action: foundation, floor and wall, which creates an extremely rigid structure. Main assembly starts on day 22. About 270 elements are hoisted every day, which is 70 elements per crawler crane per day, giving 10 minutes per hoist during daytime. Here you see 44 floor and 43 corridor elements being hoisted into position during the morning, and the walls of the second floor level. On Wednesday the third floor is assembled, and on Thursday it is the top floor. Every wall arrived fully finished. Cabinets and toilet bowls are mounted on site. All tubes are already fitted in the concrete.